Okay, welcome. This is a video on how to use the synchronous scope plot shown here. Now, I've got some plots set up and I'm going to leave those there and first show how to create a synchronous plot. So first thing, you have to pick a channel, and you see it's still not enabled. That's because it requires that you pick a trigger channel too, and this is the same as the way this will also enable the triggered plot and the synchronous plot. So we go to pick TAC, and now we can create this synchronous plot. And again, this looks a lot like the other time-based plots that we've covered. The main difference between this one and the others is, and it's quite different, is that on the x-axis it shows degrees rather than time. So it's showing number of degrees that are related to the TAC signal. So let me show this in a little better detail of how kind of what this means. And here I have the same plot up here. This is the channel 1 with a trigger of TAC, and then down here what I have is I have channel 1 and I have the TAC signal, but I have it in a duplicate channel, so you're actually seeing the raw TAC signal. And in this way you can really see how the TAC signal is basically the angle of this is a square wave, but it's easier to see in a square wave than a sine wave, but the angle of the TAC signal is really selecting a slice of the channel 0 signal. So right now you can see the TAC signal is in white, and so if I start at up here I see that there's 2 positive pulses, and if I look down here at the TAC signal, I can see that one cycle, if I say start about right here, and I go, okay, we're over 180 degrees, and then so that shows under and then down, and then we go over another 180. So between this point and this point is 360 degrees, and so that corresponds to this angle up here. And you can see basically within 360 degrees, one cycle of this TAC signal, we have 2 positive pulses, and you can see that the pulse goes low right at 360, and it's also low at 0, and that corresponds to what you see here. So this is really what's happening under the hood, and you can see that if you change the phase of the TAC signal, which I'm going to do now, you can't see it, but I'm going to shift the phase with the simulator, and you can see that it's sliding. The TAC signal is essentially selecting a little window over the top of into the channel 0, or the signal we're interested in. So now you can see it's 0 degrees. It's right at that midpoint of the square wave, and then so we would expect to see a half positive pulse, which we do, and then a full pulse, and then half of another pulse. So this is what it's doing, and it's showing 360 degrees of the signal reference to the TAC. And this would be equivalent to 1 per rev, but you could have your TAC ratio not be that. It could be some other number, and it would still behave the same way, trying to capture 1 revolution. And in those cases where you have more than 1 pulse per rev, you would see 3 or 4 pulses or whatever, and it would use that as 1 rev, and you'd still end up with the same thing. So it's using the TAC ratio as part of this. And you can also, in the synchronous scope plot, so it's 360, you can also change the setup. I'm going to do it over here so we don't have to block the screen. You can take it to more than 1 rev. So now you're seeing 650 degrees. So, and then you could go down below that. So that's what the synchronous scope plot is doing, and basically showing you what a signal is doing over 1 rev of an engine effectively.